Today I want to talk to you, with you a little bit about our experiences at Zattoo when we started to bringing machine learning models really to production. And to just start right off, I mean, you've been here at this conference already for a few talks, and I'm quite sure you came across talks that dealt with machine learning. Like, it's a topic that's everywhere. You maybe know this quote, like, data is the oil of the 21st century, and machine learning is the combustion engine. So you hear about all these great things you can do with machine learning. You saw models of recommenders who just spit out top ace recommendations. And in a world with basically unbelievable amounts of data, machine learning will finally bring you the solution to all of your problems and turn this data into value for your customers. So it should be a no-brainer, isn't it? Like, everything should be machine learning in every company. But it's not the case, as you know. You can see that a recent study just found that only half of the companies so far have adopted machine learning. Like, most of them are still evaluating, looking to it, and the other half is early adopters mostly, just still doing their first steps, and just a small fraction of about 16% is like really deep into machine learning on an organizational level. And it gets even worse because the International Institute for Analytics found that less than 10% of all machine learning models that get developed ever make it to production. This means that 90% of the work that your data scientists and other people put into these algorithms is for nothing, will never bring any value to any customer, will not bring value to your organization, and will just like die somewhere in the hell between setting up a model and bringing it to life. So why is that? I think the reason for this terrible return is that many companies underestimate the challenges that lie ahead of them when they have a model and want to bring it to production. And I think reason of this is also the success stories we hear. Like, we hear stories of machine learning from large companies mostly. It's like the Googles, the Facebooks out there who really transformed their business based on machine learning. But those stories, those success stories, usually they go something like this. And then we hired 250 specialists. In this case, it's Swisscom, who like ramped up their team like to really 250 analytics and machine learning specialists to get this going on their organization. And you already see the problem here. Like, what if you are a company that doesn't have unlimited funds, that doesn't have unlimited resources? So for example, if you're a company like Zattoo, so what you see on this image is pretty much the whole company. It's half the size of the machine learning team of Swisscom. And still, we tried to bring machine learning to our company and ultimately to our users, to our customers. So I really want to share with you how we did this. In the next 20 minutes, I want to share how we introduced machine learning to Zattoo. And my goal is, if you're thinking about doing the same maybe in your company, that I can share some of our learnings, some of our anecdotes, so you can avoid some of the potential pitfalls and problems that may come across on your way to a product. So the first thing you do, of course, is you start by building a team. But if you think that hiring an engineer is hard, you should try hiring a machine learning specialist these days. So what did we do? First, we started hiring within. Like, we already had the talent in our company. And I'm quite sure that if you work in a tech company, you also have the talent already in your company. Because if you look around, I'm sure there are colleagues out there at your company who are already deeply interested in machine learning, maybe dabbling around it in their spare time, who are really interested in this topic and would be eager to do more. And this is pretty much what happened at Zattoo. So to give you a little bit the origin story, it all started, which is, I think, the best case, with a real problem our company had and with a real use case. So we wanted to introduce recommendations for our users. So Zattoo, for those who don't know it, we are like an IPTV company, so we let our users watch television via the internet. And the problem here is, in Switzerland, you have over 300 channels. Each of these 300 channels has like a back catalog of 7-day catch-up. So you have vast amounts of content changing every week. And for the user, we just needed to find a way to bring the content he really cares about up first, so they can watch it. But the problem we had was that all third-party solutions that we tried failed. Like, the outcome were just not okay. The reason is that, like, television is a little bit a different thing than, for example, just a movie recommendation service. Like, we have much more contents. Half of the contents appear just new in this specific week and are out again in the next week, so we have hardly any user data on new content. Also, we have much more content, not just movies and series, but also news, sports, talk shows, like all the variety of modern television. So these third-party solutions didn't really work out. We can't rely on explicit feedback, like we don't have ratings on our website. All we have is basically what our users watched and didn't watch. And what happened was that one of our iOS engineers, together with our ops manager, really took the time in their spare time. They met after office hours to work on this problem together. And they came up with an algorithm that only takes like implicit feedback, like the watches of a user, as training data. So we only look basically what the user is watching after 15 minutes as an input for our algorithm. And then they created, with the help of a static data set, a prototype that was running on a laptop. And you can see like this prototype here. It's like this vector representation of TV content. And with this prototype, they went to our CTO, presented the prototype, made it visible that this is really a valid solution to our problem. And this is how it all started at Zattoo. But of course, if you have a model, you don't have a product yet. So on the way to the product, we had some issues. So first of all, we thought about, okay, how should a team look like to bring this really to production? It was easy, we thought. So we have a machine learning specialist. He's the guy who's doing all the algorithm stuff. So he pulls the data that he needs for training from our data warehouse. He sets up the algorithm, makes it pretty much ready to use. And then we have our middleware engineer who writes the APIs and puts the recommendation in front of our users. Unfortunately, it wasn't that easy because we really underestimated the work of other departments that need to go in. So we had a lot of people at our company that put in extra hours, especially like members of our data engineering team who helped build the data pipeline, members of the ops team who helped us setting up the servers, setting up the infrastructure, making sure that our recommender doesn't crash on the first day when we bring it to production. And they too wanted to feel appreciated for their contribution. So, and this was also a mistake I made, so right personally. So I talk to the data scientist and he talks to the data engineering guy. I talk to the middleware engineer and he talks to the ops guys. And together they set something up. But when I talk about machine learning, I didn't talk about them. And they need to feel appreciated as well, because as you can see, this is a model that highly relies on your corporate culture. It needs to be a culture where people feel appreciated, they are ready to put in the extra effort next to their normal day job to get a project like this off the ground. And for this, it's really important to also give out credit where credit is due. So with this learning, how would I make it different maybe the next time? I want to present you therefore my machine learning mini dream team. This is not like the people you should hire, but it's the roles you should really define and who you should really make part of your machine learning efforts as a company. So first of all, it's a person that many already want to skip. It's the data scientist. I mean, there's tons of free algorithms out there. There's many open solutions for pretty much every problem you can think about. So why not just take a ready-made algorithm, put it on a server, problem solved? Not that easy, as you can expect, because you really need this guy, because his work is to do all the research that is necessary to really understand what's going on. His job is to make sure that the algorithm you're using is not a black box for you. So what he does is he goes out and finds an algorithm that more or less fits to your problem. But then he digs in. He really learns everything that is to learn about this algorithm. He understands why he produces the results it produces. And then he's able to adapt this algorithm to your specific problems. Like, there's no one-size-fits-all approach in machine learning, and every problem has its specialties, and you need this guy to really understand it. And more importantly, sometimes things will not work as expected. Sometimes your algorithm won't spit out the results you're looking for. And then it's important to have this machine learning specialist who can tell you why this happens, who's able to really look into the problem, who's really able to find solutions together with you to make this algorithm really work for you. This is also a quote I came across. A scientist can discover a new star, but he cannot make one. He would have to ask an engineer to do it for him. So we initially also made the mistake of assuming that our machine learning specialist could also build the data pipeline. This, however, turned out to be not possible. The requests that we really needed to build like the static data set were one thing, but to have a data pipeline that delivers like huge amounts of data on a daily basis in a stable way is just too complex really to manage. So what you would also need in your machine learning dream team is the data engineer. So he's really responsible for the correct input or for the data pipeline towards your system. He knows all the limitations of your data warehouse. He knows where to find the data. He knows how to build the queries so they don't crash every time when you try to run them or run for hours and hours and not producing maybe the results that you want. He was also able to really push this data to the machine learning service so we can have our training data ready in time. So this is really also a crucial role that shouldn't be mixed up with the data scientist. And last but not least, you would also need a software engineer who works really closely together with your operations team. So her job is to get the model and transform it in a way that makes it ready to use on production. So for example, for our recommendation system, we had one huge data vector that has as a content all the contents that all of our users have watched in the last month. But on the television, you also have only like a week window of contents that are currently airing. So what we needed to do was to take this huge model, chop it into smaller pieces that fit to the current TV program, and then build our APIs around it. And this was really the job of our software engineer. And you really need him also, or her, to really be close with the ops guy to make sure that this architecture works, that this can run really stable and bring value to our users. And basically you need all of them three. You need a data engineer who works for the correct input. You need the data scientists who make sure that the model works as expected. And you need a software engineer who's then ready to bring this model to production. This is also the thing that we learned on the way. It is easy, as our operations manager put it, to get one recommendation from a machine learning algorithm, but it's very hard to get 2 million in under 200 milliseconds. And that's what it really is about. And I think that's also where lots of models really fail on their way to production, to take this into account. I remember a situation where we were at a recommendations conference together with our operations manager, And all the talks were just about how great those algorithms are, like how many percent they presented better results than the baseline, like how smooth they were, like how efficient they were. But nobody talked about how can you bring this ever to production, like how long takes the training session, how well do they perform in front of real users, or how fast can you query this model? Like these are all important questions that you need to answer before you can deploy this to the real world. But even with a perfect team setup, which we had not initially, you still need to master the way from a prototype to a product. And this is basically where I came in. Like I joined Zattoo over a year ago as a product manager, and this was my responsibility. And when I joined Zattoo, I remember my first days, I had a meeting with our data scientists and our operations manager, and they showed me the demo that you saw with the recommendations. And I thought, oh man, my job is pretty much done. There's the recommender, data works, so going to be ready like in a month or so. Like what's there to do? Just hook it up to a server, apply the APIs, done. No, that was not how it turned out. It took us really almost more than half a year to really get this to production. And yeah, I want to tell you like a little bit the steps we had to take to really get there. So first of all, it wasn't just a big release, it was an evolution. So we took the prototype and made a concept how we can tweak it to really give out the performance and reliability that we need. Then we built an MVP that allowed a share of our users at least to use the basic functionality of our recommender. We used a very slim architecture and just made sure we have a fallback whenever the architecture failed, so our users won't ever see like a black screen. Then we took care of all the architectural improvements. You need to make a service reliable and scalable. And now we are finally just getting at this stage where we can start to improve the service itself by tweaking the algorithm, extend use cases, build additional features, and so on. So it really started with our laptop. This was just a prototype. So our algorithm worked fine in the beginning, but we also had a few problems. So first of all, only a static data set. Also, it was quite heavy. So it included the usage data of millions of users dating back for months. Querying it was much too slow, especially if you have to take a TV use case where only a tiny percentage of the programs is actually currently airing. So most of the returned recommendations for this recommendation demo were utterly irrelevant for the current use cases. So in the next step, we built a simple architecture that worked for just the basic use cases. So this meant we just built a stable data pipeline. We created a service that takes the big model with all the recommendation and slices it down to a smaller model that only has the recommendations in there that are relevant for the current week. Then we made these recommendations available via API and matched the data back to our EPG data. So this was pretty much our MVP product with which we could go live. But this we really just did to verify that the model is working as expected. So we showed this to our users in A/B tests, and thank God it really helped. Like it really had a large uptick in user interactions for us, especially for movies available on replay or upcoming movies. Like this worked really fine. But even though this was already in front of users, it wasn't a ready product yet. There was no load balancing or anything. There was no redundancy. So if this one server we had the problems, there were no recommendations for nobody. There was also no staging environment. So every change of code that we did, we had to do to the production system. And there was also no way of testing changes to the algorithm. We just had one model server who calculated one model, and that's it. So this was really a problem, and we had to do what every product manager hates most, which is investing in the architecture. So this was really torture for me. Like this phase, it took a few months to really set up additional servers, to set up a staging environment, to set up the load balancing, try to come up with a solution for an A/B testing framework where we could test different models against each other. And for a product manager, this is the hardest time because all of this doesn't create a single bit of value for any user. In the best case scenario, if you do everything right here, the user won't see any glitch. So he won't see any change on the website. But this is really an important step to take because I think most of your developers are familiar with this situation. So you have one tiny mistake, and this tiny mistake brings down the whole system and brings down your whole service. And this is really what we wanted to avoid. And we are just finally now at the point where we overcame this danger, where our service is finally resilient enough to put really into production at a larger scale. And now we are ready to think about new use cases. So for example, now we can add more features, we can cover more use cases, we can extend the training data, and also very important, we can also start with A/B testing of different models and changes in our algorithm, which was not possible before. So now we have a perfect working algorithm for recommendations, so the job of the machine learning team is done. No. I think the next biggest step that we as a company also need to take is to move machine learning from a feature that we want to develop to a service that serves the whole company. Yeah, I'm sorry, I didn't find a better symbol image for feature to service. If you have one, let me know. So, you all know machine learning can do much more than recommendations. So how can you make this happen? So first of all, you need to become an advocate for machine learning in your company. You need to make sure that everybody in your company has at least like a vague understanding of machine learning, how machine learning problems look like. So in an ideal world, they can come to you and tell you about their problems, and you can think about solutions together. And we did this really short by just asking everybody in the company 3 short questions. It's, do you wish you could sometimes predict the future? Can you provide historical data about how things happened in the past? And would it be okay for you to be wrong sometimes? Because this is something that you always be aware of, like machine learning, as if it gets really good, it's right in 95% of the time, but not in all percents of the time. So this is something that you should also stretch when you talk to your colleagues. And it really was the case. Like some of my colleagues approached me later with their own ideas, what we could do with solutions that, or with problems that maybe could be helped with machine learning solutions. So for example, we had some use cases that we wanted to look at. For example, we wanted to predict user logins for our server peak times. We wanted to predict user churn to tell like who are the users who are going to leave Zattoo in the next month. Because if we identify them, maybe we can talk to them in a different way and make them stay a little longer. Also, we wanted to predict users who do an upsell. Or also can take whole other ways. For example, when we work with video. This example, what you can see here, is an example for dynamic encoding. So dynamic encoding, the idea behind this is you have an algorithm that produces an image by reducing the bitrate of this image more and more, and you have a second algorithm who determines if this image is good or bad, if the quality is good or bad. And together they play against each other until they come at the optimal solution. And what you can see here, the top image is generated by such a GAN algorithm. It has 3,200 bytes. The image below is a standard JPEG image. It has the same bitrate. So you can see the huge differences in quality. And for us, we are a video company, like this could be really, really valuable, you know. Reducing the size of our streams could improve like both our storage costs, but also, for example, the stability when you try to stream a live stream via Wi-Fi. So the important thing here to take away is, where does your company really spend a lot of money? It's like, this is probably the point where you can help with machine learning. Also, where do your user complaints come from? For example, in our case, streaming interruptions with Fire TV. And where are your processes inefficient? And this is where you can probably help with machine learning. But even if you do everything right, you will come across pitfalls and problems. We as well, we run into a lot of problems, and if you start to implement machine learning at your company, you will do as well. So this is not to avoid those problems, but just to face them when they come. And they will come, no matter how hard you try, they will not. So first of all, the biggest problem is over-engineering. When you do machine learning, the whole world looks like a nail. And this is the story that I told you earlier. Like, we had this idea, okay, we could predict logins on our server, because for us this is a really costly operation. And we could just predict how many users will log in the next half hour and already preload this data. So when everybody logs in during the World Cup finals, our servers won't crash. Great idea. And we talked to our operations manager, and he said, oh yeah, that's a really great idea. It's really fancy. So you want to set up a data pipeline, host an additional service to predict those users, and also have something in place if the algorithm fails or isn't reliable enough. Sure, we could also just increase like our server capacities. Costs much less, can be done in a week, it's easy and foolproof. So this will be a problem when you come across. Not all problems require a machine learning solution. It's sometimes hard to accept, but it's the case. Second problem is crappy data. You think you got a great data warehouse, but you will come across the cases where the data you're looking for is missing because there were some outages in the tracking, where it's mislabeled data, or where the data is just labeled, just not available in the quality that you need. So you need to really make sure that your data input is okay, because if you put crappy data in, you will get crappy returns out. And the largest problem you will face with machine learning is biased data. And you will face bias in your data. Even if you think there is none, your data that you have is absolutely objective, there's always bias. So for example, we had this issue with our Tatort. Everybody in our company got recommended the Tatort. People who loved Tatort and people who hated Tatort, hated the guts of Tatort. And the problem is that this is one of those weird contents that everybody watches. So it really tore apart our recommendation engine, because if a hipster loves Tatort and a grandfather loves Tatort, then the hipster will get recommendations for the stuff that a grandfather likes, which is usually not the right thing. But there's also more cases of bias, for example, broadcasters who always air their, maybe a better example. So usually users who watch The Simpsons at Zattoo got recommended Tough. Why is that? Because Tough was airing right after Simpsons, and most of the people just let their TV running through. So the algorithm thought, oh, those two contents must be really similar to each other, which they are not, as you know. So you will find bias in your data. Just be aware that you have to take care of it, and also have to take care of it at the root. So really, to sum up really quickly what you should do if you want to introduce machine learning at your company: you should use and enable the existing talent, but ensure that all roles are covered and that also credit is given out appropriately. You should start small and then potentially or patiently growing larger from there. You should focusing on the value for your customers, not on the machine learning for the reason itself. And you should become an advocate for machine learning in your company by being aware that machine learning is not always the best solution for your problem. That's it. Any questions? No? Thank you.